Today's episode is made possible through the continuing support of my old friend Gina Higdon and dozens of other people just like you on Patreon. If you're interested in supporting this and helping build robots and cool projects and teach people about engineering and science and technology, check out the links below in the description and see how you can get involved. Not just in Patreon, but you can also get in the huge community of Discord as well. Check the links, have some fun. Thanks, guys. Hi there, guys. Welcome back to the shop for episode 32 on Project Archi, where today it's the same thing we did the last time. Just, there's 6 motors, man. So we got to do the same thing all over again. But I learned some things. I have an elite hack happening here. I'm a firm believer in do the best you can with what you have where you are. Now, I did this. I went down that path and it was okay. It worked. It got us through the last episode. But these, my concern is these are going to damage the aviation plugs if I keep doing that, the GX16-4s. And I don't want to do that. There's plenty of opportunity for me to screw this up and break things in my own way. So let's not just invite that. If all you have is a pair of vice nuts, wrap some electrical tape around the end and you can make a set of soft jaws. Just put like 4 or 5 wraps of plain old cheap electrical tape on there. Don't use your good stuff for this. Use that crappy old roll that's half dried out and curled over at the edges in the bottom of your tool bag. That's what you use for that. Put like 5 wraps on there and you should be fine. What I am doing, however, I originally was like, why don't I do this in the vise? I have a vise with soft jaws because I have soft jaws. These are awesome. You can get these in my Amazon store. They're magnetic soft jaws. It's just a plastic jaw with magnets in the back. But I was like, well, if I do it in here, I got to elevate the robot up because the leads are so short. So I'm like, what am I going to do? I have this little gualong ding dong crappy device. Oh no, that's a Bessie. That's a good one. They all look alike is the problem. You can be careful when you buy little vices like this. A lot of them are really crap, but Bessie is a good brand. That's good vice. All my vices are devices. But this will take my soft jaws and they mostly fit. They sit like a 16th high, but who cares? What the soft jaws let me do, because they have the round hole, is I can grab our GX16-4 aviation plug. And here, I'll show you how this works. I can take the nut and the ring off, because we're going to deal with those separately. And I can make sure that my key is up, right? You can see the key. And I can flip that right the way around, set it into the flange. The flange is on top of the vice plates. Now I know my orientation is right. And I can just clamp that down. And you don't have to like, clamp it down. No, you don't need that because you just got to keep it from wandering around. And the thing is, the mass of the vice is so much higher than the vice grips that, I mean, this thing weighs like, I don't know, 8-10 pounds. But now I can hold that right there and I've got a perfect shot. You can exactly see what I'm doing. The downside is it's a little harder to spin around because I either got to move the whole vise or I got to take it out and spin around or whatnot. So we'll play it by ear. We'll figure it out as we go. But this is better. I like this better. So step 1. I know a lot of this might come as a surprise to you, so pay really close attention because we haven't done exactly this before. It is a little different. Step 1. Before we stick it through the hole, run your nut. Now remember, the nut's got the curved side, okay, where they're rounded over. It's got the flat side. You want to have the flat side biting into the inside of the box. So the curved side is the one that goes up the wire. So drop the curved side up there, then drop your ring on like that, and just let those settle down up in there. Then this is going to come out the middle hole on the left side. Because this is J2 J1's on top, 2's in the middle, and 3's on the bottom. We already did 3 in the last video. So if you get confused, look at the last video and it'll show you where we're at. So we're going to come out a bit. Now, I'm going to scoot this up as tight as I can to the vise, just to minimize the amount of stuff we have hanging out. And I might... That'll do. We're going to utilize a laptop. I am going to jack this up, but just a little bit. I'm just going to... Oh, that's heavy to pick up with one hand. We're going to set that on there, and that just bought me 1.5 inches of shortening up the motor leads. Yeah, that's better. Can I do it twice? Let's grab 2 laptops. We'll set that out there. Is it a good idea to set a big heavy robot on a laptop? Probably not, but it's an Asus, it'll take it. All right, we'll set that there. We'll slide this over. You're still got a good shot. You got a good shot. Oh, you're looking at me, I'm sorry. All right, so we're good there. And we're gonna wanna have those all land about there. So it's still about the same. We're gonna have a fist, a good solid fist, the iron fist. So we're gonna bring it out for a fist and cut those all off. Now we just gotta strip it. Okay, all of our wires are stripped. Now, they're all stripped a little long. I have to trim each one of these off, but it's no big deal. And the reason they're all stripped a little long is because my strippers, I just leave them set for Wagos. They're all set to just about 1 centimeter. I use these a lot in my, my big electrical bag, which you're gonna see a video on soon. I'm actually gonna be talking about that. And Wagos, you strip it 1 centimeter for when you're working like 90% of the electrical work I do is 12 gauge stranded THHN and working with Wagos or outlets or square D load centers. So these are just set for that. It's trivial to change them, but I don't even think about it. Just trim this stuff down. So we already know where we're gonna wanna trim them down to. I'll show you. I'm gonna get my measurement here. So that is how far I trim these down to. It's just a few millimeters. It's not very long at all. You can just line one up to the next. And these don't have to be exact. The idea is if they're too short, you're gonna melt the wire a lot trying to get it into the cup. If they're too long, then you run the risk of the leads shorting out to each other. And really, as long as they're long enough that you have a little bit of clear wire coming off the end of it, and short enough that no matter how you twist it around, they can't short out to each other, then you're fine. So here's a bit of reference. You'll need this. Okay, when looking at the plug, at the back of the plug, the solder side, and the key is up, that's your orientation. Black, green for the top, then red, blue for the bottom. And that's your color chart. See, I made you a special little color chart. If I was really cool, I'd have like colored it in. After you cut your leads off, blow all the little things out of the way because copper slivers suck. Okay, so we're gonna begin by putting some goop on things and tinning it. I'm using this. It seems to work well. I am in no way saying that you have to use this flux because I'm relatively new to soldering. I'm okay at it, but I'm still new enough to it that I don't have the opinions yet. Talk to anybody who does serious soldering, it's a holy war. It's a holy war. They all have deep, ingrained opinions about what type of flux to use and what type of solder to use. And I'm not saying they're wrong. I just don't know any of them yet. So I don't have those biases yet. So I was just like, oh, that looks good. I mean, that looks like it does something. And when I put it on there, the wire sticks. So maybe I'm doing it right, maybe I'm not. Warming up my Hako works a lot better if you plug the soldering iron in. I recommend that. There are people that can do this like cordless. I'm not one. Heck, that's not true. I have a cordless soldering iron on the wall right there, but I'm not using it for this. That's for soldering quadcopters in the field. I'm home in my shop and have my awesome Hako. So I'm just loading up a brush. And this is a flux brush. These are super cheap disposable little brushes specifically for putting flux on things. Before you use a flux brush, pinch it and pull on all the hairs and see if you can get rid of any loose ones. You will have loose ones. All right, so I'm going to just load a gob of flux on there. Like this is the lowest of tech systems. And we're gonna have to hold that. Now I got things to hold everything. I gotta hold this. Just gonna set it right there. Oh, that actually works pretty good. Okay, cool. I'm smart. I'm going to dip my tip in flux. I don't know if you're supposed to do that or not, but when I do, it comes out really shiny clean. Don't breathe that. Causes the state of California. All right. So I'm gonna come in here. I should clean that off of there. There, that's better. Okay. I'm gonna put a little bit of solder on my tip because in doing that, that pretty much tins my lead. Just touching it on there. So that's cool. And that's one tinned lead. Then we go on to the next one. It's an easy job. I make fun of it because we got to do it 6 times, and if I don't laugh about it, I'm just going to die. You can do this. If you've made it this far in the project, you can definitely handle this. I don't suck at soldering, but I wouldn't say I'm good at it, and I'm certainly not like comfortable with it like this. I'm pretty comfortable with soldering on circuit boards. You want to put a pretty healthy gob of solder on there because you're going to use a lot when it hits the cup. This is a cup type solder connection that we're doing into the back of the aviation plug. I'm probably using too much flux, but I don't really think you can use too much flux. And then black. And yes, I know using a drill press vise for this, or a milling machine or vise, or whatever you want to call that, is gross overkill for this, but there ain't no engineering like over-engineering. Okay, so my leads are all tinned. Let's get a real look at them. They're a little gungy. It may not be terribly pretty, but it'll do, much like myself. All right, so now we're going to put some flux on. Should I do these? Yeah, I should flux all of these just en masse to start. Okay. And now I'm going to attempt to fill. We're going to go front to back maybe, just because of how this is arranged. I'm going to attempt to fill this solder cup with solder. Yeah, that'll do. All right, and then I'm going to put the black wire in it and see if that'll work. I may have a little bit too much solder in there. That almost, not quite, but almost shorts out on the thing. So we'll see how I feel about that in a minute. I'm going to do the red cup. And then load the green cup. Put that right in there. And then fill the blue cup. I got way better at this by the time we did the second one. I'm pretty proud of that. Okay, that one's a little tricky to get over there. All right, I think I got all those. Let's see how it looks. Checking my color code. Red and blue on the bottom, black and green on the top, so we're good there. Oh, that's fine. It's a little ugly, but if I give that just a tiny bit of heat, I can pull. Yeah, that's totally cool. All right. So we got our wires attached, and it doesn't look bad. A little bit of a wiggle and a tug. We're cool there. All right. So now we just got to get all of that in the hole. This is actually the hard part. So I'm going to take this down off the laptops. We won't need those for this stuff, but I'll bet the laptops are back for the next video because that actually worked really good. Try and get you a view of what's going on here. So I'm going to pull the wires back in. Make sure your key is up. That's super important that the key is oriented up. Now in theory, ostensibly, this should be easier than the first time I had to do this because we're not as far down the hole. And I am on. That's actually way easier than the last time. Okay, cool. I feel good about that. Now I'm going to grab my wrench and a pair of pliers, and I'm going to open the pair of pliers thus. These are called slip joint pliers, okay? If you have a pair of pliers that look like this, and you can open them wide and adjust that for grabbing smaller things, or open them, slide that back, and grab wider things. Now for this, yeah, that'll work just fine. So I think it was 19 that fit that. It is. and I can seam a thing and tighten that. And you just want to hold it vertical, and you're only going to get a tiny little bit of a turn at a time. But you're not going for tight. Don't reef on this because you'll pull the layers apart on the 3D printing really easily. And I'm grabbing the ring. There! Done! Time! Yes! It's in. It's good. It's lovely. Here, I'll show you guys. This is going to be a sideways view, but you'll get to see it. Focus! There you go. Look at that. I like that. Yes, I know it's a little bit kitty-wumpus from one to the other, but I don't really care at this point. It's in, it works, it's good. So that's our second one. That's the J2 motor connection. And when you come back on the next one with a different size wire, we'll be doing, that's kind of odd, we'll be doing the J1 motor connection. But for now, that one is done, and I'm going to tuck the wires way down under in the box. We got one. I'm glad that's done. Let me know how it went for you. Comment. I'm curious to see what little hacks and tricks and jacking thing up and moving things around that you're using to be able to get these in there and get them done. That's it for episode 32. You guys have fun. Thank you for hanging out with me. If you're interested, if you don't have one of these and you want one, check out the link below in the description to Annan Robotics, and that's where you can get this kit. It's entirely designed by an amazing human being named Chris Annan, who is quite possibly one of my heroes at this point, because he designed this whole thing on his own. He just, one day he's like, I want a robot. I'm gonna build a robot. So he built a robot, and he's like, this is a cool robot. Other people should have robots. I'm gonna make a kit and share my ideas. And he did, and it's entirely out there, and anybody can build this. You can buy all the parts for it at, like, they're all off-the-shelf components except for like the machined parts. He sells a kit already done with all those. And if you can't afford that, you can 3D print all the parts. I went on hard mode because it's shiny, and I like the shiny. But this whole thing is a kit. You can get the actual robot parts from Chris Annan from his website, Annan Robotics. You can get all the other parts on like McMaster Car and Amazon and stuff like that. It's super cool. And my job is teaching people about science and engineering. So I saw the kit and I was like, this is neat. I want to do this. Now I like robots. I've got serious robots, but the difference is that's a $15,000 robot. This is only a few grand. You just have to put it together yourself. And that's hard. There's a lot of steps to that. So I'm like, all right, let's do this. Let's teach people how to put a robot together step by step. I have no idea what the hell I'm doing, but I'm figuring it out. He wrote an instruction manual that doesn't suck. I'm trying to make it better. And we're doing a whole set of videos step by step of building this entire robot. And we just completed the 30-second one. So thank you guys for hanging out with me on this. And maybe another 30, 40 videos from now, we'll have a damn robot. It'll be pretty cool. You guys have fun. I'm Chris Boden. And as always, I'll see you next time.